Good afternoon and good morning and whatever, everybody. This is the Net.lol podcast. I'm Tom Nadeau, one of the co-hosts, and I'm joined here with my other co-host, Brent Salisbury, and Dave Tucker. Mr. Mastery can't make it today. Today we're joined by a couple of folks from Kontain, Serge and Mark Davis. Thank you guys for being on the program. This is a very interesting topic. The first time I heard about this topic, when we talked, I said, "Wow, we gotta talk about this. This is some interesting stuff." And I guess that's a good introduction to kind of get, maybe you guys can introduce who you are and what you do, and we can start from there. Just let the listeners know, where you guys are from, what's the tech, and then maybe we can talk about why the way you guys do containers is a little different from the kind of the canonical way that's being done today.
Cool. I'll start, and thank you for having Serge and I on this, guys. It's really great to be talking to you. Serge, so I'm Mark Davis. My co-founder here is Serge Pashenkov. This is our second company we founded together. We started a company in 2007, 2008, which was a very high-performance snapshotting file system company for virtual machines that VMware purchased. And so this is Serge and I's second go-round of co-founding a company together. We tend to like finding problems that look fairly difficult, that no one seems to want to try to solve, but that need solving. And certainly Kontain is in that same vein. So I am the one guy at my company who no longer writes software. So Serge is the guy who actually builds the software. I'm sort of the business side of the company these days. And so Serge, will you please introduce yourself?
Serge Pashenkov. Yes, I do write software. And it is our second go around with Mark. And it's been a great challenge because we believe that the world needs this.
So what's different about the way you guys do containers versus why? Well, explain why. Sorry.
Well, we believe that if somebody would start from scratch writing an operating environment for the use case of containers, nothing like Linux would be even close to that. The reason for that is because Unix at large, has been conceived for an entirely 100% opposite use case. Been conceived for the use case where we have a huge machine, multi-million-dollar machine shared between dozens or even hundreds or maybe even thousands of people and applications. And there is a lot of effort that went into those kernels to allow sharing of resources. You think about containers, it's actually 100% exactly opposite. Each container is supposed to be in its own little micro world, using resources that are dedicated to this container, talking to the world through a very narrow, very well-defined communication point. And so the technology that we invented actually is going exactly that use case. So the rest of it is basically how we do it, but that's the main reason. And because containers, Docker containers, standard containers, are on the shared kernel, there is a lot of effort that went into that kernel to allow for that use case, and there is a lot of new code that went into that kernel. And, well, you know what new code means. New code means new bugs.
New bugs, right?
And new bugs means new exploits. And we've seen a lot of new exploits, specifically in the code that is enabling containers.
That's where a lot of the vulnerabilities have been, yeah.
Yep. So that's what we do.
So it's interesting. I mean, you talk about like the shared resource part. So like, what's different in your scheme versus the more typical schemes for containers today?
What we do is we package the code that executes each microservice. So we're specifically going after the use case where microservices are packaged in the way of containers. We believe this is a perfect match, like match made in heaven from the workflow point of view. So what we do is we take the code that is implementing each particular microservice and we package it, as you mentioned that name, unikernel. Unikernel means that every single piece of code that this particular user level code needs is linked in together in a single executable, if you will. But the trick is that nothing that this thing doesn't use gets in. So it's a
And
little
that's really
tiny,
what's different, right, between that
and
and the current model, right?
that's exactly what's different, and that's 100%. And because there is no sharing, and that's where it's becoming very important. The implementation of that services for the user level code is could be much simpler and much more efficient. Because if you think about it, there is a lot of code in the Linux kernel that is specifically dedicated to arbitrate between multiple users. Like
Right,
one
and that was
program
first
writes it.
added for regular virtualization and then adapted
Absolutely,
again
yes.
for the
Yeah, and
service.
adapted. First, it was actually invented for just time sharing
Yep.
between users, and then adapted again, and then again. And so what we do is we package it as a unikernel. Now, again, unikernel is something that's very deep underneath, and the people who are using it are not going to see it really.
So why is it different? This is like gets to the heart of like what's unique about the way you're doing it, right? Like if you can explain to folks, I don't think everybody here understands A, what a unikernel is, and
Understood?
B, like why the way you're doing it is a little different too than what I think the average person would look at and say, oh, that's a unikernel.
Yeah, well, let me take it. Let me tell you a little bit of the sort of the why. Serge can talk more about the how.
Yeah,
So
please.
one of the so the original idea of containers was, I mean, there's a reason we invented containers. We didn't just keep packaging everything as virtual machines. It's because at some point virtual machines became so big, so heavyweight, so complex that they just were untenable when you're trying to deploy stuff um, that you're
This is like the
packaging.
superset of what Serge was talking about, though, right? It's
Yeah,
it's the super kernel, right? It's the
yeah. So
entire
you've got this.
kernel and the whole
There was,
machine and the whole damn thing, right? In a VM.
it was crazy, right? It's not crazy. It was perfect for its time, but we sort of evolved and realized we need to
Yeah.
build and package and deploy and operate software differently. So this thing we can't keep packaging these giant things every time we want to do things. We got to boot an operating system that's got a million files in it and has all this
So it's
complexity.
not
All I
just
want to do
it's
is
not just time to boot, it's also space to, in memory and on disk and everything else, right?
resources. It's just
That was the whole premise. So
it's
just to,
overly complex and it's unnecessarily complex, right?
yep.
So containers were meant to simplify, which is great, and in some ways they did. But the original idea of containers is we want to be able to fire up little units of work. We can call them microservices if we want to. We want to fire up little units of work which are highly independent of any other unit of work. They are extremely strongly isolated from each other, meaning we could run lots of these at the same time, and they can't interact with each other directly in any way except over a well-established, public network API. Other than that, they don't talk to each other. They aren't sharing memory. They aren't using semaphores and all the other stuff building operating system kernels. And these things may well be highly ephemeral, and they may or may not be running on the same machine or on the same subnet or even in the same data center. Right? That was
That's a good
the
point
idea.
too, the ephemeral nature of them. I mean, that's one of
Yeah,
the whole shticks of, autoscale, right? I can have
right.
a million of these atoms or I can have one. And I
Yep.
can make a million of them in as fast as time as possible. That's been the premise for this. The problem has been that, if I need another atom, if I launch a VM as another atom in
Yep.
this picture, there's like 80% overhead that you probably don't need, that you've got to
Yeah.
fire up, allocate, yada yada yada, right?
Yeah. And that
That's
was the
exactly right.
and so containers were meant to get us to this world we could do this. And the problem was, I think, because it's a difficult, problem, to build the right runtime infrastructure. The most expedient thing to do when the containers were being invented was, let's just take this thing called Linux, which of course has been around for many decades and it's tens of millions of lines of code and all that stuff. But hey, let's make that thing be the platform for running these containers because hey, it works and it's there and if it can do all the things it can do, we can shrink it down into something smaller called a container. And it was an expedient and useful idea.
It was the best bet at the time.
Yeah, it was a good bet, and again, there's nothing wrong with it. But at some point, it seemed obvious to Serge and I that at some point we're going to get to where, first of all, trying to run lots of small, supposedly independent objects on the same kernel was asking for trouble from a security point of view. And as you mentioned, Tom,
and as we've seen,
tons of exploits of these things. Second problem was, we wanted to have this idea of this perfect ephemerality that you described, Tom, but the reality is we don't really have it. We got closer to it, but we're not really there, right? It's much more efficient to start a container than it is to start a virtual machine, but it still isn't so efficient that you can treat things as essentially zero cost to start ephemeral objects, right? The cost,
especially for things that require near instantaneous scaling. Or near instantaneous repair. I mean, that's hard.
And well, it's not just hard; it's impossible because the truth of the matter is you can't start a container, in a standard container in 4 milliseconds. You can't, it's going to take you on the order of a second. Maybe it's a handful of seconds, depending on what's running in that container and how it's built. And for a lot of things, that's fast enough. But for a lot of things, that's an eternity, right? So,
reminding folks what we're talking about. It is, like use cases for this are things like hyper trading, which people are talking about different kind of machine learning activities for self-driving cars and things. These are things that could potentially use these things in very low latency situations that need it, like that, right?
Yeah. Yeah. And so
just want to make sure folks are understanding where we're going with this.
Yeah.
Well, even for the networking nerds among us, it was many years ago now, but there was a great research paper on something called Jitsu, which allowed unikernels to be spun up to respond to DNS requests. Like every request could be responded to by its own freaking unikernel. Like that, that's pretty cool. It's definitely a very cool technology.
Yeah, that's exactly where we're going. And you actually mentioned something which is very interesting. You said from 1 to a million. It's interesting to note that you didn't say 0. Because in your head, there's an assumption that you need at least 1 to allow for low latency. But if you can really start quickly enough,
right. Well, that's the other thing too. The startup penalty is so high, you would just make 1 to begin with. That's been the kind of the canonical approach, and that is effectively a waste of that resource that's sitting there, not, unless it's rocking at 100%, right?
Absolutely. And like Dave mentioned, respond to DNS request or respond to first request through HTTP RESTful or whatever it is. We can do it.
It takes longer to bring the machine up than it takes to do the whole request and turn it around.
Right, but with containers that we produce, it does not. We actually can do it. We actually could scale from 0. And it's the same, basically, response time. And the reason is because we packaged unikernel. We created our own virtual machine, our own virtual machine monitor. It's based on KVM, or it could also be based on any other hypervisor. Today it's based on KVM. But that virtual machine is highly optimized for this little tiny use. And the reason it's optimized because the use case doesn't need a lot of things that virtual machines provide. Microservices don't need floppy drives. They don't need keyboards.
Well, and they also introduce security vulnerabilities.
100%.
Just like we did years ago with, if people remember, this was one of the motivations to get white box switches, right? A lot of vendors, web scalers got sick and tired of the feature factory problem, as I call it. where vendors would keep dumping more and more features that they didn't need, and that's where a lot of the bugs ended up. As Serge said, new code, new bugs, and all of
Absolutely.
that. And that's also a very important way to look at this too, which is you only need what you need. You don't need anything else because it invites other problems, right?
Exactly right. And so the virtual machine we created only supports the minimal set of functionality, which is actually memory and the CPU. There's no PCI bus, there's no BIOS, doesn't even boot. Instead of booting, we just start the virtual machine with memory pre-initialized with the executable code. And in fact, the first instruction that virtual machine executes is the first instruction of your payload. There is no preparation, there is no boot, there is no initialization. It just starts. That's why it's so fast, and that's why it's so small.
Yeah, yeah. That's interesting.
And at the same time, what's important is that each instance of the workload, each container, is in fact insulated by KVM technology. It's in fact insulated by standard virtual machine walls. And as you mentioned, because the virtual machine itself is so small, there is very little code in there. And so there is very little to exploit.
Right. And also the sort of prepositioning nature of how you're constructing the VM, like you're saying, the packaging. This is another problem with containers these days that, there's a big thing going on in the industry right now about base images to build containers and that whole business. And maybe you can jump into why that's different in this model, why it's less important in how you're doing this. When you create your container, like you said, you're pre-staging it all. You know exactly what goes in there.
Exactly.
And that's really. Go ahead. Sorry.
And the base image itself is basically empty because what goes in there is what's needed, and there is no a priori stuff that is needed.
Yep. Yeah, it's just the bare minimum. It's interesting too. Like I was thinking about this after we talked last time. Like there's some interesting security implications here too. Like you can tell if there are other containers running around in your network that are different because they'll have a different signature than your slimmed down, pre-built, pre-packaged as well. And this is part of one of the reasons why base images and managed base images are kind of a thing that's going around these days. But I've always thought of that as a lot of extra busy work that could be handled elsewhere. And I think you've handled it in this case, right, by setting it up ahead of time. You don't have like an ongoing scanning thing or anything needed. You know exactly what's in that box, and there's no more than you need in that box.
Well,
whereas the other containers are the whole thing, often. Or the VM that's under there is the whole operating system, whether you need everything or not.
What I would like to say, however, is it's not like we make scanning impossible. People sometimes feel like they need to scan the libraries they deal with or whatever the code they're bringing that's not theirs, or even theirs.
Even theirs, right. But you can do that ahead of time at construction time.
Correct. Exactly. And the point is, it's not like we make scanning impossible. We maybe make it a little less important and necessary, but it's still possible. And in fact, I think it's the right idea to do both because scanning protects from somewhat different vector of attack than we do.
Right. I don't mean the ongoing, the sort of active or dynamic mode, which you're right. I mean, there are libraries that are perfectly clean that can go do weird stuff. What I was referring to is the part at construction time where, base images are sort of pre-scanned and pre-configured.
Right.
And then basically duplicated all over the place as the base image, for the thing. And yours is a little different. I mean, you could do that too, right? I mean, you could do that and then insert that into the construction phase.
Correct. Correct.
But it's also, so that's maybe something to talk about here, right?
I think what I'm really interested to know. So I've been in the container space for many years and in the unikernel space for a couple of years during my container phase. But I mean, when we started out with unikernels and we were talking to users, there were really two schools of thought. One was pick a library operating system. Here's one, Mirage OS. Here's another, Illumos. Like, here's another one. Like, you pick the bits of the operating system that you need. You need networking, you link networking. You need storage, you link storage. But users were very wary of that. It was always, well, I'm never going to rewrite that application. This one runs in Fortran. There is no unikernel runtime for Fortran. Like, we're stuck. There was another school of thought, which was, let's have a rump kernel, right? Let's provide something POSIX-y, and anything POSIX-y we can probably run and just strip everything down and provide, whatever's necessary. And, there was a lot of work going on, but I never really saw anything that was really kind of hitting what users were really asking for in terms of experience. So how does Kontain do things differently? What does it look like if I am a user and I want to use Kontain? What changes do I need to make, if any?
Perfect question. I love this question. And the answer is nothing. The answer is, and that was something we started with, and you're absolutely right. There are unikernels out there, and they very well do the job, as long as you write your software in OCaml. Well, who is going to write anything business in OCaml? Well, that makes you really...
As an outlier.
That makes you really unique.
Cambridge.
If you can do it, Tucker will try it.
Okay. So what we started with is the premise that the source code is sacred and we don't touch it. We don't tell people to do pound include whatever .h and code to a different API. Nothing of the kind. It's the same. And in fact, we don't even need to see the source code. When we prepare unikernel, what we need is only object files.
So you're really just doing a linker phase
Basically,
operation.
yes.
Basically,
yes.
right?
And so the only change that we require, well, yes, the only change that we need is a tiny little change in the Docker file. Referring, basically saying, don't refer to the standard base and instead refer to us. And that's the extent of it. Another thing is, in order to run us, we package ourselves as an alternative runtime. So for instance, if you have Kubernetes cluster, you can configure the Kubernetes cluster using daemon set that we provide. And then the only difference you need to make, the only change you need to make in your YAML files describing your pods is runtime : Kontain. And that's it. And on the same exact cluster, you could run us standard containers side by side. So it doesn't have to be forklift. It could be very piecemeal approach. Could convert.
Well, that's very important, right? Because nobody has there are very few green fields. I tell people all the time, you got to transition into one of these things.
Yes, and that's exactly why we can run side by side and completely no conflict. In fact, you could run the same code in contain container, and in standard container.
Yeah.
And like green-blue deployment, and you compare the results. And when you're satisfied that the stuff works exactly the same way, then you switch all the way. Or not. Hopefully that doesn't happen, but bugs, bugs are bugs.
Well, that's the interesting thing too. Like from a user perspective, you can literally leave your CI/CD pipeline the way it is, except for the construction phase. Like that, all the testing, everything you're doing right now should still work, right?
That's right. That's exactly right.
Well, that was kind of the problem. I mean, so 2015 unikernels kind of started getting hot. Like, it's like when we were at Docker, we acquired unikernel systems, which was some folks out of Cambridge. But the problem was always like, okay, am I really expected to revamp my entire, all my tooling, everything around this to now go back and fit like this new paradigm? Like we've just now gotten to containers. Now you expect me to forklift everything. So that definitely is interesting. I'm looking on your old GitHub site, and it looks like those integrations with existing tooling around containers works here. Is all your code, so a little bit more on the code itself, is it looks like everything is open source. Is that the case?
Yes, today everything is open source. It's on the GitHub. People are welcome to, take it for a ride.
Yeah, I guess that's a good point. Is if people want to try this out, is there a good link that we can point them to, like a getting started guide, as a quick how-to on how to take a containerized app and turn it into using Kontain as a unikernel?
Honestly, I don't have it off the top of my head, but
That's fine. We can insert this in post-processing. It's the magic of
it's on the GitHub. It's I
Isn't it on the
believe you could
GitHub
just
main
start
page?
with. I
Yeah.
believe you could just start with the homepage, and there is quick reference, quick jump there to the, quick start guide and user docs.
Fantastic.
So Dave kind of got me thinking here. Are there particular applications that make more sense for users to package in a unikernel versus containers, or are you guys just saying we need to throw containers out the window completely and everything should be a unikernel at this point?
I'll sort of answer it from the opposite side of things. If you have a traditional monolithic, gigantic application that is supposed to run forever, and more often than not is supposed to take over the whole machine, like many Java applications actually do, then it's probably not a good candidate for us. If on the other hand, you're writing an application or you're making changes in the application written in the microservice philosophy, then basically everything should work.
So
But that's the case where you get the advantage.
Microservices rules apply that today as they do tomorrow. If that makes
But
sense.
but that's the case where you get the advantage, right? Where you have multiple containers that are basically sharing the unikernel. That's where you start to get the amplification of the benefit, right? Over
right.
one big machine, big VM, right? So that's really kind of the use cases where you can kind of coagulate together like-minded containers, or like-dependent containers, right? Because I can imagine that, like, as I've listened to you guys, like, you can have pockets of unikernels that are, they're kind of constellations or something, where they make sense for that unikernel, so you build them together with that unikernel, and that got me thinking, like when we talked last time. There's some more work maybe in the construction phase for users to help them figure out how to group them together. Like what unikernels, do you do any of that yet, or is this still manual?
Well, it's not really
That's
manual.
really where the optimization is, if you do it right.
What I would like to say here is that if you have two different versions of your microservice code, or if you have two maybe similar but whatever microkernel codes, the unikernel still is different for each and every one of them. So if between versions of your code you stopped using certain service or started using certain service, then that service would appear or disappear from the unikernel for this particular code.
Right, that would change your dependency map.
Exactly, and so basically every single instance, every single type. So if you have thousand instances of the same type, that's the same unikernel. But if you have 500 of this and 500 even of the next version of the same unikernel, very well could be different.
That's what I was saying. That's two unikernels and two groups.
Correct.
Or something like that. That was the one thing I was thinking about. Like, how do you evolve that in an operational environment? Because once you get past day one, as you said, when things start to add or to delete, whatever, change, you don't want them to over the next, two releases gravitate away from a single unikernel to like 50 unikernels, because then we're almost back to where we were, right? Not quite, but
no, you do want that. Like that's the whole promise, right? You have exactly the bits of kernel that you need to run the application, and it will mutate.
No, but I
But
mean the sharing part. If you could share those bits, possibly, across
Well,
containers,
that kind
maybe.
of goes against no sharing philosophy.
True,
So,
true.
so
yeah,
But just
you
a
you don't
thought
want to
of,
share. Sharing's terrible. But
yeah,
yeah,
sharing's
I
bad.
think the day two stuff, Tom, is really interesting because that reminds me of another fun user problem that we had with talking to customers about unikernels was what happens like on day two. So I've deployed my unikernel app. Once upon a time, it was really easy because when things went bad, I could just drop into a bash shell inside my container. And I'm going to assume that you guys aren't shipping bash inside your unikernels. So like what does the administrator tooling look like for trying to debug something like a network issue for something that's happening inside your container runtime?
well, we generally do not package shell or any other tools inside of the unikernel, inside of the virtual machine. Because the more tools you package, the more attack surface you got, obviously.
More problems, yeah.
Yeah,
Exactly.
we could package a shell. There is a version of the base that has shell, and that's the main reason for that is in some cases, in many cases, in fact, things like Java really wants the shell to set up the argument, to set up the options for the Java interpreter. That's the only reason. But it doesn't have to be, and in many cases, it's not.
Yeah, I kind of look at that as an operational thing. Like if you really want to deploy with debug, you deploy with a shell of your favorite kind, super constrained, but you set it up.
Yeah.
Maybe,
As far as debugging, we do provide full GDB debuggability of the running containers. So it's as easy as debugging a remote executable. So, but the trick is that GDB related code isn't part of the
isn't
unikernel.
there. Yeah.
It is actually part of virtual machine monitor. So the unikernel itself, the microservice code itself, has no access to it, and it's not even aware of its existence. So as far as debuggability and looking at the network stuff, and again, the approach is the same. All the services are not inside of the container. They are inside of the virtual machine monitor, virtual machine monitor. So only the code that a user writes, only the code that's specific to the application, and whatever little services required to run it, that is becoming a part of the unikernel.
I guess
And
there you could talk to the VM and kind of go from that direction to
that's
do the
exactly
debugging.
the way. That's exactly the way we're going. We talk to the virtual machine monitor. We're talking
Because the
to
VM knows their containers and knows how things are hooked up to the container. If you go
exactly.
the other way, it's intentionally obscured.
Yep.
Maybe that's
Right,
it.
but that typical network debugging use case that we're always really familiar with is I need to pretend I'm the application because I need to send some traffic
Yeah,
through so I can
that
get
won't
the
work here.
firewall drop logs on my firewall and see like what's happening elsewhere in the infrastructure. And that's not impossible, but it's certainly different, I think, coming into, a
That's right.
unikernel
Yeah,
environment. So it's
you'd
always
have to
good
do
to kind
something
of,
like launch another container with a shell in it while it's broken, and then try to look at it from that way or something. If to do that,
That
I
would
don't know.
work.
Something to think about. But we're up against the top of the hour here, folks. So I wanted to kind of wrap things up a little bit. This is a fascinating conversation that we must continue. This is interesting. So I'd love to have you guys back on. But in lieu of that, do you guys have any like final words to wrap things up, or for folks that are listening, Mark and Serge?
Well, I'll just I will say we just sort of barely scratched the surface here, right?
Yeah.
There's so much to talk about this stuff. I think what we've really tried to do is there is a lot of sort of elegant beauty to the idea of a unikernel, as Dave pointed out. There's a lot of correctness to it. Sort of as computer scientists, we can look at this like, this is the way this stuff ought to get done. We should not be running we should not need a 25 million line kernel to run a 3,000 line Python program, right? We should be able to keep everything small and simple and fast, and all those, the goodness in all dimensions is there if we can do that. The problem is doing it in a way that's incredibly simple and that still conforms to the way people want to do things and the way people are used to doing things. And I think, Brent, you pointed out, the shortcomings of the earlier versions of unikernels. And again, this is not criticism. They were plowing so much cool ground, but you needed to provide the benefit of the unikernel with the user experience, with the developer experience, with the DevOps experience. That is what they want, and they're not looking for something new and different, frankly. They want to keep doing containers just like they're doing because they're used to it. They have processes, they have deployment methods. Doing this in a way that is in the end of the day, it's just a container. I mean, you do not need to know that there's a unikernel inside of it. That's completely unnecessary for you to know as a developer or as a DevOps person. Doing that was part of the challenge for us. Was could we sort of reinvent the entire foundation underneath containers without the people that build the containers needing to know it, right? right. And I think that's so trying to keep this as simple as it's just a container with a slightly different Docker file where we edit one line of the YAML and everything else is the same. Doing that was sort of the design goal here, and we think we've done a good job of it. But we'd really love to hear hear feedback from people, and anybody who's listening to this podcast wants to interact with us on it. Please reach out to us. We'd love to work with you on it. It is actually really easy to use. It is almost no work to run these things, and and once you sort of switch over to having all of your workloads be super small, super fast, and super secure, life just gets easier when you do that. And so we'd love to help you get there. So reach out to us if you have any questions, comments, or feedback. If you see something we aren't doing that you'd like to have us do, hit us up. We'd love to work with you on it.
Cool. Well, thanks again, guys, for being on. This was fascinating. And again, I hope to have you guys on in the future to continue this. This is really interesting stuff. So I wanted to thank our sponsor again, T1 Nexus. If you need optics, give them a call. They're fantastic. And thanks again for the folks from Kontain for being on tonight. Thanks again. And thanks for listening to the net.lol podcast. We'll see you on the next one.